people who are actually running llm-d inside of an organization, they're responsible for standing up these internal model services that all the different applications across the organizations are going to consume.
Sounds easy.
Sounds easy when you're dealing with multi-million-dollar clusters and maybe billion-dollar clusters. These AI platform teams inside of the organizations, they have three main things that they're trying to solve. First is they have to deliver an SLA to their different consumers of the application. Now, there's all sorts of challenges related to authentication, access control. How do you decide quotas associated with who gets how much tokens does each kind of end user get? So this is one of the really key first things that we're helping these teams to reason about is how do they define and then control the SLAs that they're trying to deliver to the different business applications. The second real challenge is we're dealing with very expensive hardware. They're called LLMs. The first L is large. The workloads are getting more and more complicated. They're long context. They're if you have ever done agentic coding, you will see the thousands and thousands and thousands of tokens that are being generated for just one inference session. The cost of these things is really, really important. So the second main thing that I hear over and over and over again is people are trying to squeeze as many tokens as possible out of the GPUs. And so with llm-d, we're implementing all of these key performance optimizations that help you to do that. And then the third is really the day two operations. And I think oftentimes high performance and day two operations of how do you observe, have resiliency, consistently deploy and lifecycle. Those things often go in contrast with each other because performance optimization can be the root of all evil sometimes. And so by being Kubernetes native, by integrating into the way that everyone already knows how to deploy and manage applications and making AI inference fit into that world.
Yeah, getting all that telemetry that you need for other workloads, getting it for AI.
Absolutely. Yeah. CRDs for deployment and automation, integrating into the existing L7 networking stack that's been built out into Kubernetes. All of this Kubernetes native design principles we have in llm-d really help to make that possible.
So when you think about it, who's the audience? Who's the consumer of llm-d?
In addition to the enterprise platform teams, which is obviously a huge focus of our products at Red Hat, we also see a lot of adoption in the open source from larger model producers, folks who are really thinking about deploying kind of monolithic, single model at really, really high scale. And this kind of comes in two buckets. The first is for reinforcement learning. This is really a massive workload that many of the model creators are currently focused on, as it's helping to drive a lot of the reasoning and agentic capabilities that are coming into modern models. And inside of that RL workload, inference is actually the most expensive part of that. And so a lot of the features we have in llm-d for doing things like wide expert parallelism are extremely useful for maximizing throughput in these setups. And so we've been working with a lot of these labs on helping them with their infrastructure for doing reinforcement learning. And then secondarily, many of these labs are also deploying the models as a service for their customers. And so many of the features that we have in llm-d that really target performance are highly useful for these types of deployments, especially considering the very, very large models that many of these labs are starting to deploy. And so this is really where we've seen the most adoption of llm-d is in the enterprise IT platform teams, as well as with the model providers who are both focused on the reinforcement learning and the online serving.